In this example, we're going to determine the classification for this linear system, and we're going to do so by looking at its equations. So I can see this first equation is y equals 2/3 x minus 5. This is in slope-intercept form, and automatically I know things about it. I can grab its slope because its slope is the coefficient of my x, so 2/3, and the b value, or my y-intercept, is going to be a -5. I'm going to use these two values and compare them to the same values, the slope and the y-intercept, of this line. Unfortunately, we see that the second line is in standard form, not in slope-intercept form, so we need to go ahead and kind of adjust this and put this in slope-intercept form. That way we can grab the slope and the y-intercept and we can compare them. So the first thing I'm going to do is subtract 3x from both sides, because I'm trying to solve for the y. So -2y equals -3x plus 8. And I just went ahead and snuck that -3x in front because I want it to be in y equals mx plus b form. So I want this x term before the constant. Then I'm going to go ahead and divide every single term by this -2, so it cancels out. So y equals 3/2 x minus 4. Okay, so that's that second line. So I can say the slope is the coefficient of my x, so 3/2, and my b value, or my y-intercept, is -4. So looking at this, the first thing I'm going to do is compare the slopes. Since I see the slopes are not the same, they look awfully similar, but this is 2/3 and this is 3/2, so not the same values. I know that these two lines will cross and they'll have a single point of intersection, meaning I don't need to go any further. I don't need to look at the y values because the slopes tell the whole story. Different slopes indicate that this system is going to be consistent and independent, a single solution, and these lines will cross at a single point of intersection.